For my physics project, I am doing an example on centripetal force on roller coasters to see how high it needs to be for it to go through a loop and not fall at the top of the loop. For the top of the hill, I put V1 equals 0, and what we are trying to find is H1, which is the height. For the top of the loop, we are trying to find V2, and what we know is H2 is equal to 20 meters because the radius is 10 meters and the diameter is 2 of the radius. By going down the hill, we are going to lose potential energy and gain kinetic energy, so it will be able to gain speed. So the first thing that we have to find out is how much speed do we need to go through the loop without falling off. The first thing we are going to find is the energy, is the E2 equals kinetic energy plus potential energy. The second equation we plug it into is 1/2 mv2 squared plus mgh2, which that equals to the 20 meters, and equals 49,000 joules plus 196,000 joules, and that equals to 245,000 joules. That is the total energy at the top of the loop of the roller coaster. The second equation that we plug into is E1 equals EK plus EG, which is kinetic energy plus potential energy. And you take out the kinetic energy because you're at the top of the hill, not during the loop. So you get mgh1. So you plug in energy 1 equals energy 2, which equals 245,000 joules equals mgh. So you divide 245,000 by 1,000 and also divide it by 9.8, and you get 25 meters as your height 1.
Okay, so this is my friend Katie jumping on a trampoline. And basically, I'm going to do 1D kinematics. And yep, there she is doing a flip. She didn't land it, but that's okay. So I made up an equation. I made up a problem. So the problem is Katie can jump to a height of 2.62 meters. Determine the takeoff speed of Katie. So step 1 is to find the given. So acceleration is negative 9.8 meters per second square. The final velocity is 0 meters per second. The distance is 2.62 meters, and I'm looking to find the initial velocity. And then step 2 is plug into the equation and solve. So I'm basically using VF squared equals VI squared plus 2AD. And then I plugged all of my givens in, so I got 0 equals VI squared plus 2 multiplied by negative 9.8 and 2.62. And then I would get 0 equals VI squared minus 51.35 meters per second square. And then I'd take the square root of 51.35 meters per second square, and I would get 7.17 meters per second. So Katie's initial velocity is 7.17 meters per second. Also, jumping on a trampoline is a great way to illustrate all 3 of Newton's laws of motion. Newton's first law, which is known as the law of inertia, states that an object at rest stays at rest and an object in motion stays in motion unless acted upon by an unbalanced force. So when a person jumps and reaches their highest point, they come back down due to gravity. Newton's second law illustrates how your velocity changes with the equation F equals ma, where it is used to find kinetic energy. Newton's third law states that for every action, there's an equal and opposite reaction. When the springs are stretched, they exhibit an equal and opposite force, which propels you up in the air.
In soccer, the unbalanced force is the player's foot. Because the ball is at rest, it will continue to stay at rest. Once it is kicked, it will keep moving in a straight line without stopping. The ball will end up stopping with the Earth's gravitational pull. When I kicked the soccer ball, I transferred my momentum to the ball. The acceleration of the ball is determined by the final velocity minus the initial velocity divided by the change in time. When players pass the ball to each other, they use their feet to slow the momentum of the ball by moving with the ball and resisting it slowly. To find the acceleration of the soccer ball, I found out the final velocity was 1.8, the initial velocity was 0, and the change in time was 1.3. When I plugged that into my equation for the acceleration, I got 1.38 meters per second squared. Also, there is projectile motion in soccer. This refers to the motion of an object projected into the air at an angle with the horizontal. When the ball is kicked, the ball reaches its maximum height and comes right back down. The ball is being pulled by gravity. To find the maximum height, you use the equation v squared times the sine of the angle divided by 2 times g. In this problem, the velocity equals 20, g is always 10, and the angle of the ball is 5 degrees. Now, you plug in the numbers, so you will get the equation 20 squared times the sine of 5 divided by 2 times 10. And you will come up with the answer 1.74 meters.
For my physics final project, I compared cheerleading with stunting and physics to freefall and gravity. This is using kinematic equations to get the impact speed of a dropped object. Kinematic equations is when you integrate velocity equations with respect of time. Then you get the displacement equation. For my sample equation, S equals displacement. Then if you combine these equations, you get a third equation, the time-independent equation. An object of freefall acts under the influence of gravity and accelerates towards the ground. I am trying to find the impact speed of when my bases throw me in the air and when I come down. This equation can be used for any motion or acceleration, or even a constant acceleration motion.
In volleyball, there are many different ways that physics is used while playing. One way physics is being used is when a player goes up and hits the ball. When the ball is being hit, the player exerts force onto it, which causes a change in direction and puts a downward energy onto the ball when hitting it to the other side. When going up to hit the ball, gravity is working against the player as it is pulling him or her down. But when the ball is hit, the gravitational pull is now in favor of the player, helping the ball move downward at a faster velocity. The momentum of the ball is moving much faster because of its kinetic energy that is being placed on it by the player. From the time the ball is hit to the time it hits the floor, the distance being covered, the ball is moving in free fall or projectile motion. To find displacement of the ball traveled from the time it is hit to the time it hits the floor, one would take the speed of the time it took the ball to travel to its destination and multiply them. To find the distance the ball was going, you multiply the speed times the time. For this example, the speed was 6 and the time was 3. Multiplying them together would make 18 for the distance. For someone to find the maximum height that the ball was being hit, they would need to know the angle at which the ball is being hit. In this example, it's 13 degrees, and the velocity, in this case, is 17. To start the equation for the maximum height, you use v squared times the sine of the degree, all divided by 2g. G, in the case of physics, is always going to be 10. When multiplying all of this out, plug in all of the numbers into the set equation. Multiplying v squared, you get 289, and you multiply that by the sine of 13, which is 0.240. Divided that all by 20, and after completely doing the math, you will find that the initial height for projectile motion is 12.14.